Alright, so we're going to continue talking about functions. We've been talking about functions all week. Today we're going to talk about function notation. Do y'all remember last week when we had, we were talking about whether something was or was not a function using the vertical line test, and then we talked about function notation at the end. We're going to talk about today, there's 3 different ways to find function values. One of those is using function notation. So, if you would on your notes today, we're going to do finding function values in 3 different ways. The first way is using an expression or an equation. So, part 1a, we're going to find the values of the expression 10x plus 3 when x is equal to 2, when x is equal to negative 1, and when x is equal to 1/2. So first, when x is equal to 2, the value of the expression 10x plus 3 is, well, what we're going to do is we're going to take that 2 and we're going to substitute it for the x in that expression. So I have to zoom out just a bit. There we go, that's a little better. So I have 10 times 2 plus 3. There, now I have a little more space. 10 times 2 plus 3. So what is 10 times 2? 20. 20 plus 3 is 23. Very nice. So our input, we put 2 into the expression, and we got out what? 23. So I'm going to make a note of that at the top. So at the top here, just above where it says part 1, I'm going to say input. That's like the x value, right? Output. I started to spell function, sorry. Output is like the value of the expression. Ooh, very good. So value of expression. Can I abbreviate expression? Do you all mind? Or the y value. Perfect. Very good observation. So y'all talked a little bit about input output, yes? Fantastic. All right, so let's try negative 1. So negative 1 is my input. What's my output? So I have 10 times negative 1 plus 3. So what's 10 times negative 1? Negative 10. Perfect. So negative 10 plus 3. Perfect. Negative 7. Very nice. All right, finally, when x is 1/2, when my input is 1/2, what's my output? So I have 10 times 1/2 plus 3. So what's 10 times 1/2? 5. Perfect. So because half of 10 is 5. Exactly. 5 plus 3 is 8. My 3 problems here. I'm going to separate them there. All right. Example B. Example B here says, what is the value of the equation? So now I have an equation. See, it says y equals. So we're finding that y value when we have a given x value. You ready? All right, so I've got 2 is going to be my x value. So I'm going to move this over just a smidge. There we go. So I want to know what is y when I have negative x squared minus 3. But what is x here?
2.
2. So we're going to plug in a 2. All right. So we're doing PEMDAS. So parentheses, there's nothing to simplify inside the parentheses. It's just a 2, right? Exponents. So what's 2 squared? 4. So I have 4. I'm going to bring down my negative and minus 3. I have y equals negative 4 minus 3. What is negative 4 minus 3? Negative 7, because if we go down 4, down 3 more. So it would be negative 1 if I had plus 3, right? Very good. But I have minus 3, so I have negative 7. All right. So what is y when x is negative 1? So I'm going to plug in negative 1 to x. So I have y equals negative x squared minus 3. I'm going to plug in negative 1. So what is negative 1 squared?
Negative 1.
Oh, ooh, interesting. Oh, think about it. So what is it? What are we doing when we square something? Multiply it to itself, right? So what's negative 1 times negative 1?
Negative 1.
Positive 1, right? Because a negative times a negative is a positive. There we go. We got it. We got it. So I have positive 1, right? I'm going to bring down my negative, minus 3. So y is negative 1 minus 3. What's negative 1 minus 3?
Negative 4.
Negative 4. It's okay. You keep adding. That's okay. So remember, if I go down 1 and down 3 more, that's negative 4. All right, one more. One more for this one. I have 1/2. So I have y equals negative x squared minus 3. I almost forgot my negative out front. Oops. So then what's 1/2 squared? You may need to use your calculator for this because we have not talked about exponent rules yet.
1/4.
1/4. You're thinking 1/2 plus 1/2, right? Well, we need 1/2 times 1/2 is 1/4. So I have negative 1/4 minus 3. So what's negative 1/4 minus 3? Use your calculator. And negative 11 over 4? Or negative 3 and 1/4, right? Yes, ma'am. This way? This way? Sorry, thank you. Better? Fantastic. All right, so can I leave it as an improper fraction? No, why not? Okay, so what is it as a mixed number then?
Oh, 2 and 1 up to 8. 3/4.
Not 3.
You should just use your calculator. Isn't that what you're talking about?
Yes. Almost. Almost.
Oh, okay,
Okay, so 4 goes into 11.
3 times. For 8. For 8, 12. Yeah. 2.
It's negative 2.75. So you're right.
Negative 2.75.
I know.
Wait. Hold on.
Oh, okay.
Is that 11/4?
Yeah, like, who said
Oh, it would be if it were adding 3, right? If I were adding 3, right?
No, so yeah, we are. We're adding 3.
No, I'm not. I'm subtracting 3.
But they're both negative.
They're both negatives, right?
Yeah.
Mm-hmm.
They're both negatives, right?
They're both negatives.
So that's how we got 11 over 4. Negative.
It should be 13/4. Right? That's okay. So now what's my mixed number? Now what's my mixed number?
It'll be 3 and 1/4.
Negative 3 and 1/4. Right? There we go. So negative 3 and 1/4. Beautiful. Very good. Very good. All right. All right, finally, what is the value of the function f of x is equal to 4x squared minus 5x for f of 2, f of negative 1, f of 1/2. I'm going to bring this back down for just a second because I want to be able to point to the other ones. So what's different about this question versus what we had in example A and B.
There's more
Give her glasses
steps.
back.
Huh?
Give her glasses back.
There's more steps.
All right, there's more steps. Well, why are there more steps?
Because of what the fx equals.
F of x equals, well, isn't f of x just like y?
Well, no problem.
It is. Remember last week we said f of x is y. So, well, I've got an x in two different places, right? But what about my problem? Here, up here I said x is equal to 2, and here I say f of x. Is that the same thing? Kind of. It just looks a little different, right? Because here, f of 2, this is f of x, right? If I replace x with 2, what am I saying? I'm saying, well, what is y when x is 2? Exactly. So that's what we're going to do. We're going to replace all of the x's with a 2, with a negative 1, and with a 1/2. Okay? So let's try the first one. So I have f of 2 equals you guys. You ready? You ready?
Yeah.
Okay. So I have 4x squared minus 5x. Why did I replace my x's with parentheses? I've been doing that for all of them, but why?
Wait, what is it? F equal.
F is the function. F means the function. All right. So that's just the name of this particular function. We named it f. It could be g, it could be q, it could be any other letter. We usually default to f because f function starts with an f. All right. Why would I leave these blank? They're the x values. So I'm going to fill in parentheses with whatever the x value is. So a 2. Perfect. I gave it to you. Is it saying f of 2? So I'm asking you to evaluate when x is 2. Is that okay, Preston? Okay. So we're going to start with exponents. 2 squared is what? 4. So I have 4 times 4 minus 5 times 2. What is 4 times 4? 16 minus 5 times 2 is 10. 16 minus 10 is 6. Next, f of negative 1. So I have 4x squared minus 5x. So I'm going to replace all of my x's with a negative 1. Because that's what we're going to evaluate for. So that's going to be given. Like you'll be told what you're evaluating for. Good question. So these are the problems. So I want to know what is the function value of the function. I keep wanting to say the function of the value. What is the value of the function when x is 2, when x is negative 1, and then in just a moment we're going to find when x is 1/2. Is that okay? A little better? Yeah. Good. Question or are you stretching? Okay, good. That's fine. Just wanted to make sure we didn't have any questions. All right, so now I'm going to evaluate my exponent first. What's negative 1 squared? A negative 1 times a negative 1 is a positive 1, yes. So I have 4 times 1, remember? What's 5 times negative 1? 5?
It's negative, positive 5.
Wait. Because if I brought down my minus, right?
Negative 6.
That's a negative 5, right?
Yeah.
But you're multiplying the negative and the negative.
Oh, so I could just do that from there, right? Because that's a negative, that's a positive, right?
Yeah, that one's not squared.
It's not squared. No.
Oh, it's a positive.
5 times negative 1.
Yeah, that's wait, so that's
Hold on. So what I did originally was I just brought down my minus, right? And I have 5 times negative 1. So a positive times a negative is a negative. But a negative negative is a positive, right? Or if you saw it this way, or if you were looking at it this way, negative 5, if you took that negative and made that part of that 5, right? Negative 5 times negative 1 is positive 5. Yes, that's fine. If you see the shortcut, yeah. Because you'll get plus 5 either way. All right, so then 4 times 1 is
4.
4 plus 5. So what's 4 plus 5? 9. All right, last one here, we're going to evaluate at 1/2. Donnie, put your phone away, hon. So I have f of 1/2 equals 4 times 1/2 squared minus 5 times 1/2. Sorry. Forgot to push it up. Is that better, you guys? All right. So we're going to do exponents first. So what's 1/2 squared? 1/4. So I have 4 times 1/4 minus, what's 5 times 1/2?
5 times that is 2.5.
Yes, sir. Oh, I went ahead and multiplied. That's okay. And what's 4 times 1/4?
1.
1. So we have 1 minus 2.5. What's 1 minus 2.5? Negative 1.5, right? Negative 1.5. That it would be negative. It would be 3.5 if this were a negative 1, right? So if you go up 1 and then down 2.5, you get negative 1.5. All right. All right. So finding function values using a table. Finding function values using a table. So here I give you the x values that we're going to evaluate for. And my expression is x plus 7. So let's complete this table here. So x plus 7, I'm going to substitute negative 2 for x. So what's negative 2 plus 7?
3, 4, no, 5.
5. There we go. There we go. Negative 1 plus 7. 6. 0 plus 7. 1 plus 7. Ooh, 2 plus 7, right? 9. 3 plus 7.
Where'd you get that? Oh.
Do you see what we're doing?
Right here.
It is a pattern. All right. So now I'm going to use this table to find my function values. You ready? We were doing that a little bit yesterday. Someone's knocking. Okay. All right, so we're going to use the table to find our x values. So when x equals 0, the value of y is what? So when x is 0, so I'm going to go to the x column and find 0. What is y? 7. That's it. 7. All right, Vincent, when x is negative 2, what is y?
I know this.
You want the next one? You can have the next one. When x is negative 2, what is y? Well, negative 2, come across, we've got 5. There we go.
10.
All right. When x is 3,
It's 10.
Y is 10. Very nice. Hold on, because I've got one more question for you guys. I'm going to add one here to the bottom. Can you all add one to the bottom for me? When y is 8, x is what?
1. 1.
Look. What did I change?
The X don't, yeah.
I said y instead of x, right? So we're going to go to the y column. When y is 8,
1.
x is 1. You got it. All right. So we've done finding function values algebraically. We've done finding function values with a table. It's kind of fun. Wait, the fun doesn't stop. We're going to find function values using a graph. So on the back, if you would, turn your paper over to the back. Here it says find f of 0 and f of negative 6. So what is 0? 0 is taking the place of what? X. Of x, right? So when x is 0, what is y? When x is 0, y is 3. So f of 0 is 3. F of 0 is 3. All right. Well, that's one of them. Mm-hmm. So f of negative 6 . So I'm going to go to negative 6, negative 3. You got it. So f of negative 6 is negative 3. All right. We're going to do another one. F of 6. So I want to know when x is 6, because see 6 is taking the place of x. When x is 6, what is y? So I'm going to go to 6. 1, 2, 3, 4, 5, 6. We get 0. Is that okay? Is that a little better? All right, let's try another one. F of 11. It's 1 because when you go over 11, what's the y value on that function? 1. Is that okay?
Yes.
Good. All right. Part C. Hold on. I want to change it because I don't like that problem. Let's do f of negative 1. Can you all change that to f of negative 1 for me? You think so? Let's find out. So when I go to negative 1, what's that y value? Is it positive or is it negative?
Positive.
Can't be on your phone. When you plug it in, it's plugged in.
Positive. Positive.
It's positive. That y value right there is positive. So at negative 1, this is the point.
So you're just going to line it up?
Mm-hmm. So, I didn't. This is negative 1. Up. Because I went to the graph. The function is what we're looking at.
Are we changing the negative 4?
Hold on. We have to go to the graph. So we're looking at that function. That function is that curve, right? So at that function, what is that y value?
Positive.
It's positive. Is that okay?
Yeah.
Okay. So here, f of negative 4, so I'm going to go to negative 4. What's that y value? Negative. All the way away. I want to see it. Yes, sir.
So what if you got a question like C and you didn't change it? What would you do?
That's why I changed it, because that y value is 0, right? Is it positive or negative? It's neither. That's why I changed it. And we'd already answered that problem. We'd answered it right there. F of 6 is 0. So we'd already kind of answered it. That's why I changed it. All right, E says, for what values of x is f of x equal to 0? So I'm not looking for the x values. I'm looking for what y values are 0, right? So I'm going to look on my graph. So when y is 0, oh, look, I've got a point right here, right? What is x there?
Negative 3.
Negative 3. So I'm going to say x is negative 3. Is that the only one?
No.
No, what else do I have?
10.
6 and 10. Very good. So x is 6. X is 10.
I'll use this one better on the one.
Yes, sir. Because I'm looking for, well, when y is 0, what is x? And we're going to do some more of those in just a minute, because I know those are a little tricky. All right, we're not going to worry about f today. Let's take a look at G. So we've been talking about domain and range. So what is my domain? Domain are what? The x values or the y values?
Values.
X values. So what's my smallest x value?
Negative 6.
Negative 6. So negative 6 is less than or equal to?
Scared the crap out of me.
Negative 6 is less than or equal to what?
That's all. Okay.
X. And x is less than or equal to, what's my biggest x value? 11. Range. Range talks about
Why?
the y values. Perfect. So what's my smallest y value?
Oh, never mind. Negative 3.
Negative 3, right? So see, if I keep going across, that's negative 2, so it's just above negative 3, right? So negative 3 is less than or equal to? What variable am I going to use? Y. And what's my biggest y value? 4. Is less than or equal to 4. All right. I'm going to come back to I, J, K, and L. I want us to take a look at M and N. Hold on. I'm going to fold this so that I can take a look at those problems next to my graph. So I'm going to fold my paper so that y'all can see everything at once. Is that okay? That way I don't have to keep moving it. I think that's better. All right. It says, for what values of x does f of x equal 3? So is 3 my x value or my y value?
Why?
The y value. So I'm going to go to 3 on the y-axis. So what value gives me 3? What x value gives me 3? 0. So I can say f of 0 equals 3. Is that the only one? What about here? 4 also, right? So I can say also f of 4 equals 3. All right. What about negative 2? What x values give me negative 2?
Negative 5.
Negative 5. So f
And positive 8.
of negative 5 equals negative 2. And f of positive 8 gives me negative 2. All right, it says a set of points. I'll move that up some. A set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph at most one point. So that's another way to write the vertical line test, right? So every vertical line can only touch the graph once. Here, we had horizontal lines, though, yes? So horizontal lines can have more than one y value. Vertical lines can have only one x value. Donnie, put your phone away, hon. All right. Finally, it says if the point 5, negative 3 is a point on the graph of f, then f of blank equals blank. So here, this is my input. This is my output, right? So which of these is the input, 5 or negative 3? 5. So f of 5 equals my output, negative 3. F of 5 equals negative 3. All right. What I need for you to do is to glue these into your notes. I'm going to go to the next available page in my notes. Your box, it might be underneath one of the desks. And I'm just going to fold back the line where it says name, where you wrote your name, because you're gluing it into your own notes. So you know who it belongs to. And glue these notes into your notebook. I did that so that, and then you can fold your paper in half. That way you can see both sides.